All right, let's jump right into this explainer. Today, we're tackling something that literally shapes everything you see and remember: pattern recognition. We're going to trace this wild journey, starting from 19th century philosophy, zoom way down into the microscopic biology of our synapses, and finally zoom back out to look at modern digital behavioral tracking. Let's get into it. So, are we actually experiencing reality or just detecting patterns? It's a huge question, right? It means our perception isn't just some passive video camera recording the world. It's an active, ongoing problem our brains are constantly trying to solve. And we solve it through biological pattern detection. It's a survival mechanism that kept our ancestors alive. But as we'll see today, it's also a mechanism that modern media now actively and quite surgically exploits. This massive historical debate really sets the stage for us. For the longest time, science couldn't agree on how we actually perceive things. You had Thomas Reid on one side with his theory of direct realism. Basically, he thought what you see is what you get. Sensation and perception, exact same thing. You smell a rose, boom, you instantly know it's a rose. But then Hermann von Helmholtz comes along and says, actually, scratch that. He argued that the physical sensation is just raw data. But perception is actually a psychological inference. Our brains are constantly interpreting those physical sensations and making best guesses based on learned patterns. And Helmholtz totally nailed this by pointing to perceptual illusions. I mean, think about any classic optical illusion you've stared at, even when you literally know it's a trick. Like, you know for an absolute fact those two lines are the exact same length, you still can't force your conscious mind to override the false sensation, can you? Your brain is essentially locked into detecting the patterns it has learned over a lifetime. Helmholtz realized our minds are inferring reality, not just recording it. Okay, so if Helmholtz was right way back in the 19th century, that we are basically inference machines, how on earth does the physical wetware of our brains actually do it? Well, to figure that out, scientists went hunting for the biological blueprint of memory. They were basically looking for a literal repetition detector, hardwired right into our synapses. And wow, did they find it? They discovered this astonishing little protein called TGF-beta, or transforming growth factor beta. According to research in the Proceedings of the National Academy of Sciences, the way this protein activates is incredibly complex, acting like a literal molecular timekeeper. It is absolutely 100% crucial for forming long-term memories. It doesn't just blindly fire off when something happens. No, it waits, it tracks time, and it specifically looks for repetition. The biological choreography going on here is just wild. Scientists studied this deeply in the Aplysia sea slug, which is a total classic model in neuroscience, by the way. And here's the play-by-play. During a first learning event, a neuron secretes TGF-beta, but it's totally inactive, just latent. It docks itself outside the cell and basically just hangs out, primed and waiting. The memory is only unlocked if a second repeated event happens. That second trigger releases a protease called BMP1, which acts like a pair of molecular scissors, snipping and activating that waiting TGF-beta. So the first trial primes the pump, but it's the repetition that actually seals the deal for long-term memory. Now, looking at this data, we can see exactly how scientists hacked this system. Normally, a single pulse of serotonin, that's the neurotransmitter we're tracking for learning here, does basically nothing for long-term memory. But 2 pulses, spaced exactly 45 minutes apart, boom, highly effective long-term facilitation. That is the spaced repetition your brain naturally craves. But here is the crazy part. Researchers found that if they gave just 1 pulse of serotonin and then manually added that BMP1 protease, they sparked long-term memory instantly. They completely bypassed that natural 45-minute wait time. They essentially picked the lock on the brain's repetition detector. Now, as fascinating as that molecular hack is, it brings us to a pretty unsettling pivot in this explainer. We just saw, at a microscopic level, how biology demands very specific, spaced repetition to build meaningful connections. But if those biological rules can be completely bypassed in a petri dish, how is this same kind of pattern hacking being weaponized at a macro level by modern society? How are our media ecosystems trying to bypass our natural cognitive processing? To get a grip on this, let's look at one of the most ruthless efficiency engines on the entire internet, the adult film industry. Strictly from a data perspective, this industry acts as a massive societal repetition detector. Studios are tracking literally billions of search queries, clicks, and watch times. They are aggressively data mining the exact keywords people type, mapping out rising trends around very specific clothing or locations. Then they reverse engineer those exact patterns directly into their video titles and scripts. They aren't guessing what people want. They are using real-time analytics to feed the collective human brain the exact patterns it's already actively hunting for. And when they throw these scripts together, they lean heavily into what's known as taboo power asymmetry. Now, just to be absolutely clear here, we're strictly talking about fictional roleplay between consenting adults. There is obviously zero tolerance for actual abuse or non-consensual content. But structurally speaking, using a deeply familiar societal power imbalance, like, say, a boss and employee, or a fictional teacher-student dynamic, means the producers don't have to waste any time building up a backstory. Why? Because that pattern is already baked into your brain from years of societal conditioning. It's a lightning-fast setup that builds instant tension. Exactly like those scientists dropping in the BMP1 protease to skip the 45-minute wait, these producers are dropping in pre-existing social patterns to bypass the need for traditional narrative engagement. So let's actually put these two mechanisms side by side. On the one hand, you've got our natural, slow biological spacing. Our physical synapses literally require those 45-minute intervals of spaced repetition just to form a meaningful, long-term memory. It's a built-in biological safeguard, making sure we only remember what actually matters. But contrast that with the quick digital setup. Digital media algorithms track our data to serve us exactly what we want, leaning on those super familiar dynamics to hijack our pattern recognition for immediate gratification. It completely short-circuits the biological wait time, feeding the pattern engine instantly. So as we wrap up this explainer, I really want to leave you with a thought to chew on. We started with Helmholtz figuring out that our brains just infer reality through patterns. We dug into the literal molecular machinery that locks those patterns into our synapses, and we've seen how modern analytics can map out and exploit those exact biological vulnerabilities on a massive scale. So, if your biological algorithms are really this easily mapped, how much of your perceived reality, your daily engagement, is truly your own choice? And how much is just your brain automatically detecting the patterns an algorithm decided to feed you? Definitely keep that in mind the next time you find yourself falling down a digital rabbit hole. Thanks for joining me today, and keep questioning the patterns around you.